Okay, let's proceed. As I just mentioned, this X bracket 1 is a first student's what? Score in the population. Okay, the population is 900 students class. And this one is a first what? Score in the sample. Okay, and you can imagine if I put student's ID, okay, follow a sequential order. So the one with smaller ID number is the first student. I can rank it, okay? And I randomly select what? 30 students. So here is X1 to X30. This is X bracket 1 to X bracket 900, okay? That means different one, idea. And as I mentioned, under H not is true, I expect to see what? Huh? I randomly select 30 students. I find the sample average should be just like what? Population average. Huh? Should be close to what? 63. Under this assumption, how likely I randomly select and select a very weak group? Only what? Average is 55. Okay? Or even worse, even less than 55. Okay? Under H naught is true. What I observe should be close to what? 63. If this doesn't close what I expect, further deviate from my expectation, that's called extreme. That means TA did a very, very poor job. That's why class average is so low, right? Now, how can I find the size of the shady area? As usual, we need to standardize what? We need to standardize X bar so we can calculate the probability, okay? And standardization goes this way, okay? Standardization, as usual. Any variable, subtract by its mean, EV X bar, divided by what? Its standard deviation, SE X bar. Any variable after subtracts mean divided by standard deviation. What do we get? We get Z score, okay? Now, as I mentioned, EV X bar, right? EV X bar. What's EV X bar? EV X bar is average of the box, or you say mu. And what's mu? Mu is 63. So this is X bar minus what? X bar minus 63. Divided by SEX bar. How can we find SEX bar? Okay, I'm going to flip to the next page and show you how we find SEX bar. Okay, it's a review of what I posted in the previous 2 weeks. Okay. What is SEX bar? The standard error of sample average. Okay. And this is SE sample total divided by N. SE sample total divided by N is SE1 total divided by N. And what's SE total? The formula is standard deviation of the box times square root N, number of rows, divided by what? Divided by N. Should I stop here? Of course not. This is the formula for with replacement. But remember the draw in our example is what? Is without replacement. So this one should be standard deviation of the box times square root N over N, and there is a term we call what? Finite population correction factor. Capital N minus little n over capital N minus 1. Okay? This is without replacement. And our case happened to be what? Without replacement. Okay? So let me try. This is our case, okay? Since we make the draw without replacement. So this is the one we want to look at. What's the standard deviation of the box? Anybody still remember from the previous page?
20.
It's what?
20.
30 傻逼.
It's 20. Am I correct? That's the population standard deviation, okay? So this one become 20. And what's the sample size? Well, look at here. This is square root n, this is n. N can be written as what? Square root n times square root n. One cancellation. Okay? So this one becomes square root n. N is what? N is 30. Okay? And then times finite population correction factor. Okay? This is called finite population correction factor. You look at the lecture notes I post for previous 2 weeks, you will find this term, okay? Finite population correction factor. So capital N is what? Is 900. What's the sample size? 30. Divided by capital N again, 900, minus 1. If you calculate this number is almost close to what? 1. As I mentioned in the previous notes, when population size is what? Is 20 times bigger than that of the sample size. Then what can you say about finite population correction factor, which is this term? This term will be just close to what? 1. So you can forget about this. And end up with what? These two is the same. Okay? These two formulas will be the same because this one is very close to 1. Okay? So let's see. Can somebody help me to find out what's 20 over square root 30? Well, calculate both for me, please. Okay?
3.65.
This is 3.65?
Yes.
3.65. How about this term?
This one is 0.9 something.
0.975 something, right? Or even bigger, right? So this is almost close to 1. You don't need to worry about it. Just look at 3.65. Okay? Anybody get this number as well?
Yeah.
Okay, good. So that is what? SCX bar. So let's come back to see the picture now. Okay? This number here is what? 3.65. Are you see? So let's look at here. $55 minus what? 52 divided by 3.65. So what is this number? Somebody tell me what's this number?
It should be negative 2.19.
How much is it?
Negative 2.19.
Negative 2.19. Good, that's what I remember. Okay, yeah, this answer is right. So what is the shady area here? This is my p-value, right? So my p-value is a probability that z-score less equal to negative 2.19. Okay? You want to copy? Go ahead. Okay?